An identifier is a name that identifies either a unique object or a unique class of objects, where the object, or class may be an idea, physical, countable object, or physical, non-countable substance. The abbreviation ID often refers to identity, identification, or an identifier. An identifier may be a word, number, letter, symbol, or any combination of those. The words, numbers, letters, or symbols may follow an encoding system IDs or longer names, or they may simply be arbitrary. When an identifier follows an encoding system, it is often referred to as a code or ID code. Identifiers that do not follow any encoding scheme are often said to be arbitrary IDs. They are arbitrarily assigned and have no greater meaning. ID codes inherently carry metadata along with them. Arbitrary identifiers carry no metadata. In some cases, even arbitrary identifiers such as sequential serial numbers leak too much information. Opaque identifiers are identifiers designed to avoid leaking even that small amount of information. Include really opaque pointers, and version 4 UUIDs. The unique identifier is an identifier that refers to only one instance, only one particular object in the universe. A part number is an identifier, but it is not a unique identifier. For that, a serial number is needed, to identify each instance of the part design. Thus the identifier Model T identifies the class of automobiles that Ford's Model T comprises. Whereas the unique identifier Model T serial number 159862 identifies one specific member of that class, that is, one particular Model T car, owned by one specific person. The concepts of name and identifier are denotatively equal, and the terms are thus denotatively synonymous. But they are not always connotatively synonymous, because code names and ID numbers are often connotatively distinguished from names in the sense of traditional natural language naming. For example, both Jamie Zawinski and Netscape employee number 20 are identifiers for the same specific human being. But normal English language connotation may consider Jamie Zawinski a name, and not an identifier, whereas it considers Netscape employee number 20 an identifier, but not a name. This is an emic indistinction rather than an etic one. Metadata. In metadata, an identifier is a language-independent label, sign or token that uniquely identifies an object within an identification scheme. The suffix identifier is also used as a representation term when naming a data element. In computer science, identifiers are lexical tokens that name entities. Identifiers are used extensively in virtually all information processing systems. Identifying entities makes it possible to refer to them, which is essential for any kind of symbolic processing. Equals in computer languages. In computer languages, identifiers are tokens which name language entities. Some of the kinds of entities an identifier might denote include variables, types, labels, subroutines, and packages. Which character sequences constitute identifiers depends on the lexical grammar of the language. A common rule is alphanumeric sequences, with underscore also allowed, and with the condition that it not begin with a digit. So foo1, foo-bar, foo are allowed, but one foo is not. This is the definition used in earlier versions of C and C++, Python 2, and many other languages. Later versions of these languages, along with many other modern languages, support almost all Unicode characters in an identifier. However, a common restriction is not to permit whitespace characters and language operators. This simplifies tokenization by making it free-form and context-free. For example, forbidding plus in identifiers means that A plus B and A plus B can be tokenized the same, while if it were allowed, A plus B would be an identifier, not an addition. Whitespace in identifier is particularly problematic, as if spaces are allowed in identifiers, then a clause such as if rainy day then one is legal, with rainy day as an identifier, but tokenizing this requires the phrasal context of being in the condition of an if clause. Some languages do allow spaces in identifiers, however, such as ALGOL 68 and some ALGOL variants. For example, the following is a valid statement, real half pi. which could be entered as real. Half pi. In ALGOL this was possible because keywords are syntactically differentiated, so there is no risk of collision or ambiguity, spaces are eliminated during the line reconstruction phase, and the source was processed via scannerless parsing, so lexing could be context-sensitive. In most languages, some character sequences have the lexical form of an identifier but are known as keywords. For example, if is frequently a keyword for an if clause, but lexically is of the same form as ig or foo, namely a sequence of letters. This overlap can be handled in various ways. These may be forbidden from being identifiers. Which simplifies tokenization, and parsing. In which case they are reserved words. They may both be allowed but distinguished in other ways, such as via stropping. Or keyword sequences may be allowed as identifiers, in which sense is determined from context, which requires a context-sensitive lexer. Non-keywords may also be reserved words, particularly for forward compatibility, in case a word may become a keyword in future. In a few languages, for example, PL/1, the distinction is not clear. For implementations of programming languages that are using a compiler, identifiers are often only compile-time entities. That is, at runtime the compiled program contains references to memory addresses and offsets rather than the textual identifier tokens. In languages that support reflection, such as interactive evaluation of source code, identifiers are also runtime entities, sometimes even as first-class objects that can be freely manipulated and evaluated. In Lisp, these are called symbols. Compilers and interpreters do not usually assign any semantic meaning to an identifier based on the actual character sequence used. However, there are exceptions. For example, in Perl a variable is indicated using a prefix called a sigil, which specifies aspects of how the variable is interpreted in expressions. In Ruby a variable is automatically considered immutable if its identifier starts with a capital letter. In Fortran, the first letter in a variable's name indicates whether by default it is created as an integer or floating-point variable. In Go, the capitalization of the first letter of a variable's name determines its visibility. In some languages such as Go, identifiers' uniqueness is based on their spelling and their visibility. In HTML, an identifier is one of the possible attributes of an HTML element. It is unique within the document. Ambiguity. Identifiers versus unique identifiers. Many resources may carry multiple identifiers. Typical examples are, one person with multiple names, nicknames, and forms of address. For example, one specific person may be identified by all of the following identifiers: Jane Smith, Jane Elizabeth Meredith Smith, Jane E. M. Smith, Jane E. Smith, Janny Smith, Janny, Little Janny, Aunt Jane, Auntie Janny, Mom, Grandmom, Nana, Kelly's mother, Billy's grandmother, Ms. Smith, Dr. Smith, Jane E. Smith, Ph.D. and Fuzzy. One document with multiple versions, one substance with multiple names. The inverse is also possible, where multiple resources are represented with the same identifier. Implicit context and namespace conflicts. Many codes and nomenclatural systems originate within a small namespace. Over the years, some of them bleed into larger namespaces. When such dissemination happens, the limitations of the original naming convention, which had formerly been latent and moot, become painfully apparent, often necessitating retronomy, synonymity, translation transcoding, and so on. Such limitations generally accompany the shift away from the original context to the broader one. Typically the system shows implicit context, lack of capacity, lack of extensibility, and lack of specificity and disambiguating capability. Within computer science, this problem is called naming collision. The story of the origination and expansion of the CODEN system provides a good case example in a recent decades, technical nomenclature context. The capitalization variation seen with specific designators reveals an instance of this problem occurring in natural languages, where the proper noun-common noun distinction must be dealt with. A universe in which every object had a UID would not need any namespaces, which is to say that it would constitute one gigantic namespace. But human minds could never keep track of, or semantically interrelate, so many UIDs. Identifiers in various disciplines, a small sample of various identifiers. See also. References.